Okay, ladies and gentlemen, let's talk about fractions. Fractions have two parts. We have the top part, 6 here, it's a numerator. The bottom part here, it's the denominator. They are fractions like 1/2 and 2/4. Now the thing about it is, 1/2 is 0.5. 2 over 4 is also 0.5. So these fractions have to be equal. To make them look equal, we can simply divide the top and the bottom by 2, and now the fractions actually look the same as well. Do remember that we could have fractions that look slightly different. We could have 6 divide 7. We don't really love this when we're doing math with them because now the numerators and the denominators are on the same level. We have 6 over 7. Well, that's okay, except that now they're all again on the same line. They don't really look at. If you have a sheet of paper here, okay, and you have various lines on it, do not try shoving 6/7 on the same line. Use 2 separate lines to be clear. Okay, use 2 separate lines to be clear. Now, that is basic fractions, but let's talk a little bit more. Oh, one other basic fraction. If I have 9/5, that of course is improper. It's an improper fraction because the top numerator is bigger than the bottom, the denominator. Now, by the way, if I wanted to reduce this, I could change it to 1 4/5, and the way I would do that, it would go from an improper fraction to a mixed number by saying how many 5s go into 9. Well, let's take a look here. I have 9 fingers up here, unless of course I'm a shop teacher, and I have 1, 2, 3, 4, 5. I have 5 of them that can be taken out. That makes one whole one, leaving just 4 left over. So I have one whole handful and 4 left over. So I end up with 1 4/5. So that's a mixed number. It's going to come in handy here as we move forward. Now let's get to what we really wanted to get to begin with. Remember that a fraction, if I were to break it up and look at it visually, I have 1, 2, 3, 4, 5, 6, 7 chunks. Now ideally they'd be all equal, but I'm not that great an artist. So if I have 6/7, that means 1, 2, 3, 4, 5, 6. Okay, 6/7. So I take 6/7. Let's say I want to subtract 3/7. That means I'm going to take 3 of these 7ths away. So I'm going to get rid of that one, and that leaves me just that section, 1, 2, 3, and that ends up with 3/7. So graphically or modeling, we can look at pies, we could look at strips. So if I had a strip here with 7 chunks, 1, 2, 3, 4, 5, 6, 7. So I had 1, 2, 3, 4, 5, 6. But I take away, get rid of 3 of them. That one I don't already have. This one I don't have now. Take away, I'm left with 3 of them. So modeling in a couple different ways. The biggest thing though is that when we do fractions, 6/7 minus 3/7, you'll notice I didn't change the size of the little slice. I didn't change the size of the brick. They are still 7ths. If I had 6/7 and I get rid of 3 of them, I now only have 3/7. So the bottom number stays the same. The top, we subtract like usual. Okay, subtract like usual. Now, let's do something a bit more challenging. If I have 1/13 plus 3/13 minus 4/13 plus 7/13, I could do something like this. Well, the thing about it is, how many do I have here? Well, I have 1, but 1 what? 1/13. And as long as the bottoms are all the same, I know that whatever I'm going to be left with is 13ths. If I said it like this, I have 1 orange plus 3 oranges minus 4 oranges plus 7 oranges, I'm going to have a certain number of oranges. The denominator stays the same because we're talking about the same type of thing the entire way through. But now let's take a look at the top. 1 plus 3, well, that's going to be 4. But take away 4, that's going to be 0. And 0 plus 7 is 7. So in essence, these cancel each other out just because they happen to cancel each other out. When I take 1 plus 3, I got 1 plus 3, that's 4. Take away 4, but now I add 7. Okay, so I end up with 7 total. Now, the other thing that we might need to be careful of is I had negative 6 fifths plus 3 fifths. Now, this is a little strange in that it's improper already, but additionally, we're already in the hole. The thing is, though, it works exactly like addition subtraction. I have fifths, so guess what I'm still going to have? Fifths. And all I really need to do is cover over the bottom and just pretend that it's that problem right there. And I say negative 6 plus 3. If I owe somebody $6 and I get 3 back, it means I only owe them 3. So adding and subtracting like fractions, not a huge challenge. So we should be able to do those pretty uniformly. I want you to practice and do the following problems. 1/7 plus 4/7 equals. Number 2, 6/8 minus 3/8 plus 1/8 equals. Number 3, negative 5/11 plus 3/11. And number 4, negative 3/10 minus 2/10. Now that's a toughie. Number 5, 6/5 minus 1/5. Okay. And number 6, 3/4 minus negative 2/4. Okay, watch that double negative. All right, from there, do those. Make sure you do the quiz. Turn it all in.